In the star grouping Orion, there is a star that has spellbound cosmologists for quite a long time: Betelgeuse. This red, very massive star is much bigger and more massive than our Sun. In recent years, Betelgeuse has been acting peculiarly. It has diminished significantly and has even started to vibrate violently. This has prompted theories that this once lively star is nearing a cosmic explosion. Yet, consider the possibility that we are really seeing the beginning of a more insidious and alarming event. Consider the possibility that Betelgeuse isn't going to detonate but rather implode on itself. Join us as we investigate the latest research on Betelgeuse and its potential ramifications for our planet. Through this exploration, we intend to understand the significant impact Betelgeuse's breakdown could have on the future of the universe. Betelgeuse is a massive star, approximately 950 times bigger than our Sun, and is among the universe's largest. However, its size comes with a cost. Stars like this have limited lifespans, and Betelgeuse is no exception. It's a ticking time bomb ready to detonate, yet the exact moment remains a mystery. Located about 650 light-years away, Betelgeuse has captivated astronomers, shining as one of our nearest stars. We marvel at its brightness, trying to unravel the secrets hidden within its fiery depths. However, only 13.3% of its brilliant energy is visible to us. If we could see its full splendor, it would surpass even Sirius in the night sky. Imagine a titanic star with a radius multiple times that of our Sun, extending past the asteroid belt and nearly touching Jupiter. Within this immense domain, Earth, Mars, Mercury, and Venus would be engulfed by Betelgeuse's immense gravitational pull. Yet, the surprises don't end there. Every 1,000 years, Betelgeuse sheds a solar mass, casting off its outer layers in a brilliant display of cosmic grandeur. A cloud multiple times bigger than the star itself envelopes Betelgeuse, shrouding it in an ethereal haze that captures our gaze. This cloud, extending 30 light-years, invites us into a grand cosmic dance, coaxing us to uncover its secrets. Let's delve further into the core of Betelgeuse, where the nuclear fusion of hydrogen creates helium in a tremendous explosion. Over time, the star's hydrogen fuel diminishes, leading to a divine transformation. As helium merges with carbon, it releases brilliance that flows through the universe. However, even this magnificent fusion has its limits. As neon merges with iron, an incredible transformation occurs. The star's gravity, released by the lack of energy output, triggers an impending collapse, pushing Betelgeuse toward a fate both inspiring and catastrophic. Stars undergo a mesmerizing transformation, progressing from the energetic blues of youth to the fiery reds of maturity. During the 2nd century BC, Chinese astronomers noted a captivating observable phenomenon. Betelgeuse's distinct yellow hue set it apart from the celestial tapestry. As the centuries unfolded, the baton of observation passed to Greek and Roman astronomers, such as Ptolemy in the 2nd century AD. In his meticulous records, he described Betelgeuse as having an orangish or bronzed appearance, a characteristic that still captivates us today. This persistent hue, observed across various cultures including medieval observers in the Middle East, adds to the intrigue surrounding Betelgeuse. The story of Betelgeuse takes another twist as we dive deeper into its erratic behavior. In 2019, the star astonished researchers by suddenly dimming. Scientists initially thought that a massive dust storm released from the star's surface obstructed our view. However, the origin of the cloud remains unclear. Some researchers speculate that a massive object, like a planet, might have disturbed the star's surface or even been swallowed by it. In recent months, Betelgeuse has become nearly twice as bright as its usual luminosity. This is surprising because stars typically dim as they age. Scientists are uncertain about the cause of this sudden increase in brightness, but they know that stellar luminosity can vary for several reasons. For example, some stars undergo cycles of bright and dim phases. Betelgeuse is known as a variable star because it changes in brightness, expanding and contracting regularly, which alters the amount of light it emits. This is a common occurrence with many stars, including Aldebaran and about 30 other stars visible in the night sky without a telescope. A seismic shift was occurring inside Betelgeuse's core, with the ejection of fiery material into space creating a cosmic dust haze of significant proportions. This dust shroud obscured a large portion of Betelgeuse's brilliant light, transforming it from a dazzling beacon to a subdued light in the night sky. Betelgeuse's brightness dropped to levels previously unimaginable. Once considered among the top 10 brightest stars, it now ranks lower than the 20th brightest. In recent months, Betelgeuse defied expectations, challenging the norms of stellar behavior. Researchers and astronomers worldwide have been fascinated by this intriguing celestial dance. Speculations abound, trying to unravel the mystery of Betelgeuse's unusual behavior. Some hypothesize that massive sunspots or dust clouds are responsible for its dramatic fluctuations, while others contemplate the possibility of cyclical patterns. Their research has uncovered the startling idea that Betelgeuse's supernova explosion might have already occurred. Yes, you heard that right. While previous estimates projected its supernova event to be thousands of years away, evidence now suggests a different story. The last observed supernova in our galaxy, the Kepler supernova, graced the sky centuries ago. Scientists have proposed a model suggesting that Betelgeuse is in the late phase of carbon burning, indicating it could be on the verge of a magnificent explosion. This positions it as a strong candidate for the next anticipated supernova event in our Milky Way galaxy. Like a grand finale in a cosmic orchestra, Betelgeuse stands as a prominent contender for the next celestial supernova in our beloved Milky Way system. However, studying Betelgeuse is like solving a puzzle with conflicting observations. There are signs of material ejections and subsequent recovery, leaning towards a mass ejection event, albeit smaller in scale compared to our Sun. The challenge lies in the current difficulty of observing Betelgeuse. Researchers have been studying Betelgeuse for years and have found that its brightness has changed over time. This suggests that the star is aging and could go supernova soon. However, there is not enough evidence to predict exactly when this will happen. A supernova is an incredibly bright explosion that occurs when a star dies. It is not harmful to life on Earth and is safe to observe from our planet with the naked eye. Betelgeuse, a red supergiant in the Orion constellation, plays a crucial role in the life cycle of stars within our galaxy. Its evolution offers a window into the future of other massive stars, providing essential clues about the end stages of stellar life and the impact of supernovae on the galactic environment. To comprehend Betelgeuse's significance, we need to delve deeper into its stellar structure, life cycle, and the broader implications of its eventual explosion. Betelgeuse, classified as a red supergiant, is a product of the late stages of stellar evolution. Unlike smaller stars, which burn their hydrogen fuel more slowly and enter a red giant phase, massive stars like Betelgeuse burn through their nuclear fuel at an accelerated rate. This rapid consumption leads to the expansion of the star's outer layers and the formation of a supergiant. The core of Betelgeuse primarily consists of helium and heavier elements like carbon and oxygen. As the hydrogen in the core is exhausted, fusion reactions begin to occur in the outer layers, leading to the star's expansion. This process is governed by the complex interplay of gravitational forces and radiation pressure, which eventually results in the star reaching its supergiant phase. At the heart of Betelgeuse, nuclear fusion continues to drive its luminosity and size. Initially, hydrogen fuses into helium in a series of reactions that release immense amounts of energy. As hydrogen is depleted, the core contracts under gravity, increasing temperature and pressure. This allows helium to fuse into heavier elements such as carbon and oxygen. The star's outer layers expand significantly during this phase, resulting in its enormous size and distinctive red color. In supergiants like Betelgeuse, this process is more complex due to the star's high mass. The core undergoes several stages of fusion, creating a series of concentric shells where different elements are fused. Each stage of fusion changes the core's composition and energy output, leading to the star's dynamic behavior and eventual instability. When Betelgeuse exhausts its nuclear fuel, it will no longer have the energy to counteract the gravitational pull of its own mass. This leads to a dramatic collapse of the core, triggering a supernova explosion. The supernova mechanism involves a series of rapid events. Core collapse. Without sufficient pressure from fusion reactions, the core collapses under its own gravity. This collapse occurs at an astonishing rate, compressing the core into a neutron star or black hole, depending on its mass. Shock wave formation. The collapse generates an intense shock wave that travels outward through the star's layers. This shock wave propels the outer layers of the star into space, creating a luminous explosion visible across the galaxy. Elemental synthesis. The extreme temperatures and pressures during the supernova event allow for the synthesis of heavy elements like iron, nickel, and gold. These elements are ejected into space, enriching the interstellar medium and contributing to the formation of new stars and planets. Light emission. The supernova releases an immense amount of energy in the form of light, making it visible across vast distances. The light curve of a supernova typically shows a rapid increase in brightness, followed by a gradual decline as the ejected material cools and disperses. The explosion of Betelgeuse will have significant consequences for the surrounding galactic environment. Supernovae play a crucial role in shaping the structure of galaxies and influencing the formation of new stars and planetary systems. The impact can be broken down into several key aspects. Stellar feedback. The energy released by the supernova will inject turbulence into the interstellar medium, affecting the formation of nearby star systems. The shock waves from the explosion can compress gas clouds, triggering the birth of new stars, or disperse them, inhibiting star formation. Elemental enrichment. The heavy elements produced in the supernova will be dispersed into space, enriching the interstellar medium. These elements are essential for the formation of rocky planets, life, and future generations of stars. Galactic evolution. The death of massive stars like Betelgeuse contributes to the ongoing evolution of galaxies. The balance between star formation and destruction shapes the structure and dynamics of galaxies over cosmic timescales. Potential impact on Earth. While the supernova explosion of Betelgeuse is expected to be a spectacular celestial event, it poses no direct threat to Earth. However, it will offer a unique opportunity for astronomers to study the processes involved in supernovae and their effects on the galactic environment. As Betelgeuse continues to evolve, astronomers are closely monitoring its behavior to gain insights into the final stages of stellar evolution. Future observations using advanced telescopes and instruments will provide valuable data on the mechanisms driving the star's changes in brightness and size. Key areas of focus include monitoring brightness variations. Continued monitoring of Betelgeuse's brightness will help determine the underlying causes of its fluctuations and refine predictions about its impending supernova. Spectral analysis. By analyzing the star's spectrum, astronomers can gain insights into the chemical composition of its outer layers and the processes occurring within its core. High-resolution imaging. Advanced imaging techniques will allow astronomers to observe Betelgeuse's surface in unprecedented detail, revealing features such as convection cells, sunspots, and potential mass ejections. Theoretical modeling. Computational models will play a crucial role in simulating the internal dynamics of Betelgeuse and predicting the timing and nature of its eventual supernova explosion. In conclusion, Betelgeuse's journey from a massive red supergiant to a spectacular supernova is a captivating chapter in the life cycle of stars. Its eventual explosion will not only be a stunning celestial event, but also a critical moment in the ongoing story of galactic evolution. Understanding Betelgeuse's role in this process will provide valuable insights into the future of our galaxy and the cosmos as a whole. Key takeaways. Betelgeuse is a massive red supergiant nearing the end of its life, poised to explode as a supernova. The star's recent fluctuations in brightness have puzzled astronomers and sparked interest in its eventual fate. When Betelgeuse explodes, it will enrich the interstellar medium with heavy elements, influencing the formation of new stars and planetary systems. The supernova explosion will be visible from Earth, offering a unique opportunity to study the processes involved in stellar death and its impact on the galactic environment. Future observations and research will continue to shed light on the mysteries of Betelgeuse and its place in the broader context of stellar evolution and galactic dynamics.